Welcome. Today we're diving into the fascinating world of acids, bases, and pH. These concepts might sound like something from a chemistry lab, but they actually play a huge role in our everyday lives. From the foods we eat to the cleaning products we use, acids and bases are all around us. In this video, we'll break down what acids and bases are, explain the pH scale, and show you real-life examples you encounter daily. By the end, you'll see chemistry in a whole new light and maybe even impress your friends with your knowledge. Start with acids. Acids are substances that have a sour taste and can react with metals. You might not realize it, but you probably encounter acids every day. For example, the tangy taste of lemon juice or vinegar comes from acids. Even the fizz in your favorite soda is due to carbonic acid. Acids are not just limited to food, they're also found in nature and even in our own bodies. For instance, your stomach produces hydrochloric acid to help digest food. So acids are everywhere, playing important roles in our lives. You think of acidic foods, citrus fruits like lemons, oranges, and grapefruits probably come to mind. These fruits are packed with citric acid, giving them their signature tartness. Tomatoes and pineapples are also acidic, as are fermented foods like yogurt and pickles. Even soft drinks and sports drinks are acidic, which is why they can sometimes make your teeth feel sensitive. Next time you enjoy a glass of orange juice, remember you're tasting the power of acids in action. Acids aren't just in our food, they're also in many cleaning products. For example, vinegar, which contains acetic acid, is a popular natural cleaner. It's great for removing mineral deposits and cutting through grease. Some bathroom cleaners use stronger acids like hydrochloric acid to dissolve tough stains and limestone. While these acids are effective, it's important to handle them with care and follow safety instructions. So next time you're cleaning, check the label. You might be using an acid without even realizing it. Now let's talk about bases. Bases are substances that feel slippery to the touch and often have a bitter taste. They're the opposite of acids. Bases are also common in our daily lives. For example, baking soda is a mild base that you might use in baking or cleaning. Soap and many household cleaners are also basic. In our bodies, bases help neutralize excess stomach acid. So just like acids, bases are everywhere, quietly helping us in many ways. You might be surprised at how many basic substances you use every day. Baking soda or sodium bicarbonate is a classic example. It's used in baking to help dough rise and in cleaning to scrub away stains. Soap is another common base, making your hands feel slippery when you wash them. Ammonia, found in some glass cleaners, is also a base. Even antacids, which help relieve heartburn, are basic substances that neutralize stomach acid. Many cleaning products rely on bases to get the job done. For example, ammonia-based cleaners are great for cleaning glass and cutting through grease. Laundry detergents and dish soaps are also basic, helping to break down oils and dirt. These products work by reacting with acidic stains and neutralizing them. Just like with acids, it's important to use bases safely and follow the instructions on the label. So next time you're cleaning, remember that chemistry is hard at work. Understand acids and bases, we need to talk about the pH scale. The pH scale measures how acidic or basic a substance is, ranging from 0 to 14. A pH of 7 is neutral, like pure water. Numbers below 7 are acidic, while numbers above 7 are basic. The further from 7, the stronger the acid or base. This scale helps us compare different substances and understand their properties. It's a handy tool for scientists and for anyone curious about the world around them. Let's look at some examples to make the pH scale clearer. Lemon juice has a pH around 2, making it very acidic. Milk is closer to neutral with a pH around 6. Baking soda, on the other hand, is basic with a pH of about 9. Household bleach is even more basic with a pH near 12. By comparing these everyday items, you can see how the pH scale helps us understand the world in a new way. Do you know you can test pH at home? Litmus paper or pH strips are simple tools that change color depending on the acidity or basicity of a solution. You can dip them into lemon juice, soap, or even tap water to see the results. Some science kits even let you make your own pH indicator using red cabbage juice. It's a fun way to explore chemistry and see the pH scale in action right in your kitchen. Acids play a crucial role in our bodies. For example, our stomachs produce hydrochloric acid to help digest food and kill harmful bacteria. The acid environment in the stomach is very strong with a pH of about 1-2. This helps break down proteins and keeps us healthy. However, too much acid can cause discomfort, which is why antacids are sometimes needed. So acids aren't just in our food, they're essential for our health too. Bases are important in our bodies as well. Our blood, for example, is slightly basic with a pH around 7.4. This balance is vital for our health. If the blood becomes too acidic or too basic, it can cause serious health problems. Our bodies have natural systems to keep this balance using buffers that neutralize excess acids or bases. So bases help keep our internal environment stable and healthy. Acids are found throughout nature. Rainwater is naturally slightly acidic due to dissolved carbon dioxide forming carbonic acid. Some plants, like pine trees, produce acidic substances that affect the soil around them. Even in the animal kingdom, ants produce formic acid as a defense mechanism. These natural acids play important roles in ecosystems, helping to shape the environment and support life. Bases are also present in nature. For example, limestone and chalk are basic minerals that can neutralize acids in soil and water. Some plants prefer basic soils while others thrive in acidic conditions. In lakes and rivers, bases help balance the pH, supporting aquatic life. Nature uses both acids and bases to maintain balance and support diverse ecosystems. Acid rain is a well-known environmental issue. It forms when pollutants like sulfur dioxide and nitrogen oxides mix with rainwater, creating strong acids. Acid rain can damage forests, harm aquatic life, and erode buildings. Understanding acids and their effects helps us find ways to reduce pollution and protect our environment. It's a reminder that chemistry isn't just in the lab, it's all around us. In an acid and a base mix, they react to form water and a salt. This process is called neutralization. It's a common reaction in everyday life. For example, when you take an antacid to relieve heartburn, you're neutralizing excess stomach acid. Neutralization is also used in agriculture to balance soil pH and in wastewater treatment to make water safe for release into the environment. Do you know acids can affect your teeth? When you eat sugary foods, bacteria in your mouth produce acids that can erode tooth enamel. This process leads to cavities and tooth decay. That's why brushing your teeth and limiting sugary snacks is important for dental health. Some mouthwashes are slightly basic to help neutralize these acids and protect your teeth. Baking is a delicious example of chemistry in action. Baking soda, a base, reacts with acids like vinegar or lemon juice to produce carbon dioxide gas. This gas makes cakes and cookies rise, giving them a light, fluffy texture. Understanding how acids and bases work together helps bakers create perfect treats every time. Acids are essential in cooking too. Vinegar and lemon juice are often used to marinate meats, making them tender and flavorful. Acids can also help preserve foods, as in pickling. Even in salad dressings, acids add a tangy kick that brightens up the flavors. So next time you cook, remember you're using chemistry to create delicious meals. Soap making is another everyday example of bases at work. Traditional soap is made by reacting fats or oils with a strong base like sodium hydroxide. This process, called saponification, creates soap and glycerin. The base helps break down the fats, turning them into a substance that can clean away dirt and grease. It's a great example of chemistry making our lives cleaner and easier. Any of our favorite drinks are acidic. Soft drinks, sports drinks, and even coffee and tea contain acids that give them their unique flavors. For example, phosphoric acid is added to colas for tanginess, while citric acid is common in fruit-flavored drinks. These acids can affect the taste and even the shelf life of beverages. Just remember, moderation is key, as too many acidic drinks can affect your dental health. Acids play a role in medicine too. Antacids are basic substances that help neutralize excess stomach acid, providing relief from heartburn and indigestion. Some medicines use bases to balance pH or to help deliver active ingredients effectively. Understanding how acids and bases interact helps pharmacists create safer, more effective treatments for patients. Acids are important in many industries. For example, sulfuric acid is used to make fertilizers, while citric acid is used in food processing. Acids help clean metals, produce batteries, and even make dyes and plastics. Their ability to react with other substances makes them valuable tools in manufacturing and production. Bases are just as important in industry. Sodium hydroxide is used to make soap, paper, and textiles. Ammonia is used in fertilizers and cleaning products. Bases help neutralize acidic waste and are essential in water treatment plants. Their versatility makes them key players in many industrial processes. Acids can cause corrosion, which is the gradual destruction of metals. For example, rust forms when iron reacts with acids and moisture in the air. This process can weaken structures and damage vehicles and appliances. Understanding how acids cause corrosion helps engineers design materials that resist damage and last longer. Bases are powerful cleaners because they react with oils and fats, breaking them down and making them easier to wash away. That's why soaps and detergents are so effective at removing grease from dishes and clothes. Bases also help neutralize acidic stains, making them a go-to choice for tough cleaning jobs around the house. Acids are responsible for many of the flavors we love. The sourness of citrus fruits, the tang of yogurt, and the sharpness of vinegar all come from acids. Chefs use acids to balance flavors and enhance the taste of dishes. So the next time you enjoy a zesty salad or a tart dessert, thank acids for the delicious experience. Acids can change the texture of foods. For example, adding baking soda to beans softens them during cooking. In Asian cuisine, alkaline noodles are made with a basic ingredient that gives them a unique, chewy texture. Bases can also help tenderize meats and improve the texture of baked goods. It's another way chemistry shapes our meals. Acids help preserve foods by creating an environment where bacteria can't grow. That's why vinegar is used in pickling and why lemon juice is added to jams and jellies. The acidic conditions prevent spoilage and keep foods safe to eat for longer periods. This simple chemistry trick has been used for centuries to store food. Acids are great at removing odors. Baking soda, for example, neutralizes acidic smells in your fridge or shoes. Ammonia-based cleaners can eliminate tough odors from surfaces. This is because bases react with acidic molecules, breaking them down and making them less noticeable. So if you want a fresher home, bases are your friend. Gardeners often test soil pH to see if it's acidic or basic. Some plants, like blueberries and azaleas, prefer acidic soil, while others thrive in neutral or basic conditions. Adding materials like sulfur can lower soil pH, making it more acidic. Understanding soil chemistry helps gardeners grow healthier plants and bigger harvests. Farmers use bases like lime to raise the pH of acidic soils, making them more suitable for crops. This process, called liming, helps improve soil structure and nutrient availability. By balancing soil pH, farmers can boost crop yields and maintain healthy farmland. It's another example of how chemistry supports our food supply. Artists sometimes use acids to create unique effects. For example, etching involves using acid to carve designs into metal plates, which are then used for printing. Acids can also be used to age paper or create interesting textures in paintings. This creative use of chemistry adds depth and character to works of art. Bases are used in art restoration to clean and preserve valuable works. Mild bases can remove acidic residues from paintings and sculptures without damaging the original material. This careful use of chemistry helps museums and collectors keep art looking beautiful for generations to come. Batteries use acids to generate electricity. For example, car batteries contain sulfuric acid, which reacts with lead plates to produce electrical energy. This chemical reaction powers your car's starter and electronics. Understanding how acids work in batteries helps engineers design better, longer-lasting power sources. Water treatment plants use bases to neutralize acidic pollutants and make water safe to drink. For example, adding lime or sodium hydroxide raises the pH of water, removing harmful substances. This process protects public health and ensures clean, safe water for communities. Acids react with metals to produce hydrogen gas and a salt. This reaction is used in laboratories to study chemical properties and in industry to clean metal surfaces. It's also why acidic foods shouldn't be stored in metal containers. They can cause corrosion and spoil the food. Bases like sodium hydroxide are used in the paper-making process. They help break down wood into pulp, which is then formed into paper. This chemical process makes it possible to turn trees into the pages of your favorite books and notebooks. Acids are used in the textile industry to help dyes bond to fabrics. This ensures that colors stay vibrant and don't wash out easily. The right balance of acids and bases is crucial for producing high-quality, long-lasting textiles. Bases are also used in textile processing. They help remove natural oils and impurities from fibers, making them easier to dye and weave. This step is essential for creating soft, comfortable fabrics that we use every day. Acids can be used in environmental cleanup to remove contaminants from soil and water. For example, certain acids help dissolve heavy metals, making them easier to extract and dispose of safely. This process is part of many environmental restoration projects. Bases help control pollution by neutralizing acidic emissions from factories and power plants. Scrubbers use basic substances to remove harmful gases before they reach the atmosphere. This technology helps reduce acid rain and protect the environment. While acids are useful, they can also be dangerous if not handled properly. Strong acids can burn skin or damage materials. Always use protective gear and follow safety instructions when working with acids at home or in the lab. Respecting these substances keeps you safe and lets you enjoy their benefits without risk. Bases can also be hazardous if misused. Strong bases like drain cleaners can cause burns and should be handled with care. Always store cleaning products safely and keep them out of reach of children. Understanding the risks helps you use bases effectively and safely in your daily life. Wrap up: acids and bases are everywhere, from the foods we eat to the products we use and the environment we live in. The pH scale helps us understand their properties and how they interact. By recognizing acids and bases in our daily lives, we can make better choices for our health, home, and planet. Chemistry isn't just a subject in school, it's a part of everything we do. Thanks for joining us on this journey through acids, bases, and pH.